Hey everyone, in this video we'll discuss the different stages when building a large language model, including model design, dataset engineering, pre-training, preliminary evaluation, post-training, fine-tuning, and final testing and evaluation. These stages are not always strictly sequential in a real-world environment and could sometimes overlap. Nevertheless, using this representation would make it much easier to illustrate and explain the LLM creation process. The initial phase we discussed, model design, involves AI strategists and developers selecting the neural network architecture to employ. For example, they might choose transformers, CNNs, RNNs, etc. Additionally, they must decide on the model's depth, number of layers in the neural network, and the total parameters it will contain. The architecture choices at this stage will determine the scope of work and what the model can and cannot do. There's a popular saying among data practitioners that a model is only as good as the data used to build it. Undoubtedly, the dataset engineering phase is crucial, involving the collection, cleansing, and structuring of training data for the model. There are two main ways to acquire data to build an AI model: scrape publicly available data from the internet, or use proprietary data. But few companies possess enough data to build an LLM with proprietary data only. Many AI strategists, like Bernard Marr, agree that the companies that own the most proprietary data will likely have a competitive advantage when building AI systems. It's essential for AI developers engaged in dataset engineering to consider key ethical issues, including data diversity and building datasets that address various biases. Once these preparations are complete, the pre-training phase begins, involving training the model on a large corpus of raw data from the dataset engineering phase. During pre-training, we obtain a raw version of the model. But, depending on the pre-training data, the model could provide undesired outputs. For example, if we trained it with Internet forum data, the model could provide output responses containing offensive language and different biases. Moreover, we might be building a model that will be used for a specific domain. And when a model trained on general data needs to be used in a specific industry, we need to adapt its outputs to meet the specialized requirements of the field. Suppose you're working on a customer support chatbot. In that case, you want to train the chatbot to reply in a customer-friendly way that corresponds to client expectations and the service they use when talking to human customer support personnel. So, AI developers evaluate the preliminary performance of the model and gain an idea of its capabilities. Once they understand what needs to be improved, they'll address these issues in the post-training phase. Post-training consists of two steps. First, AI developers use supervised fine-tuning with high-quality data to improve the pre-trained model. In the second step, they'll refine the model by incorporating human feedback, like annotations. The next phase of model development, fine-tuning, updates the model's weights to enhance its quality and speed. For example, by changing weights, we can make a model smaller and faster, better suited for a specific task, and less capable in general performance. Lastly, in the final phase, we again test and evaluate the model. This time, we are much stricter and want to put ourselves in the end user's shoes. We aim to evaluate the model's response quality, accuracy, speed, and, crucially, its ethical behavior. In the next section of the course, we'll discuss model evaluation and how it's performed in practice. Thanks for watching.